We have now discovered 5,000 other planetary systems. So it's quite likely there's some kind of life somewhere, and that we're not that unique.
How was the universe before we arrived? Are we alone in this vastness? Or do we have company?
Are aliens real?
They're real, but I haven't seen them.
That kind of data should be released and shared with scientists.
Were they, I guess, human or non-human biologics?
Non-human.
There's a whole fleet of them. Look on the essay.
The universe was born roughly 13.8 billion years ago. Humans have been around for only 300,000 of those years. A blip, a blink, a fraction of a fraction. Since then, humans have evolved endlessly in the pursuit of one thing.
We have some innate need to kind of answer who are we, why are we here.
This insatiable quest turned cavemen into scientists. Science that fueled centuries of technological development. Everything we've built, from telescopes to rockets, ultimately leads to the inevitable question. How did life begin?
Even on Earth, अगर आप evolution का tape reverse करेंगे और फिर you rerun it आगे, you may not end up with us.
Priya, welcome to SparX. I am particularly excited about this episode. As you know, I think that I have a huge interest in science, and you are very much on the forefront of cutting edge research in astrophysics. And it seems like it's also astrophysics as having this golden moment, or perhaps golden decade, I would say, for last, this is where most exciting stuff is happening. So, just
First of all, thank you so much for inviting me for this conversation. Really excited to share what's going on in terms of latest discoveries.
Basically your day job is to think about black holes. आप दिन भर black hole को study करते हैं, उसके बारे में research करते हैं, and you are also at the forefront of really finding out some lot of original things that as a humanity we did not know. Is that what you wanted to do growing up? It sounds like one of the coolest job in the world.
Yeah, I think that I always fancied myself as a little bit of an explorer from when I was a little kid. And, someone who wanted to test and understand things that at the moment seemed like a limit, something that was a limitation.
Right.
So, I was a very curious and inquisitive child. And this is not...
You grew up here in Delhi?
No, I grew up mostly in Delhi. I was born in Coimbatore, grew up a little bit in Chennai. And then my parents moved to Delhi. And so I grew up mostly in Delhi. All my formal schooling was in Delhi.
Right.
I was very curious and I would be experimenting. So when we were in Chennai, I have very fond memories of this. We had a big garden and there were these tanks where water would be filled. And I would sink into the water with various toys to see which ones would float and which would sink. And
Right.
so I think always wanted to understand things in a deep way.
And somewhere like in your childhood, you told yourself that I'm going to be a scientist or I'm going to study astrophysics. Like, how did
No,
that?
I think I was not that careerist. I mean, my mother's a sociologist. My father was a civil engineer. And so, but then he moved to engineering education. And he was actually with the government of India. He was the director of the Association of Indian Universities. So very much in education. And, our family milieu, my parents' friends, they were all academics, basically. And so I think I knew that I wanted this life where I could figure things out. and that would be a nice thing to do.
See, I want to share something with you. I also grew up a place nearby, Haridwar, and I distinctly, some of my fondest memories are, रात में हम लोग घर के ऊपर छत पे सोते थे. And you were lying down looking at the sky, and उस वक्त तो at least sky बहुत clear होता था. You will see
Pollution वैसे हरिद्वार में अब भी शायद दिल्ली जैसा बुरा हाल
कम होगा, but उस वक्त तो you can in fact अगर रात में देर तक जगोगे तो मिल्की वे भी दिख जाता था, उतना क्लियर होता था. And as a kid you always wonder what's out there. I think every kid goes through that. But at some point your life happens, we get busy, but you have been basically wondering about what's out there.
I think I was also very fortunate. I often say that I won the birth lottery. So I, very early on, my parents bought me a telescope and a microscope, and it was probably 7 or 8. And मुझे काफी जल्दी समझ में आ गया कि मुझे क्या पसंद है. I like the fact that, जैसे आप कह रहे हो, that you're looking out at the night sky and it's just the wonder of it, right? I think to me, the fact that through the telescope, you can see far, it kind of comes tantalizingly close. But चाहे आप कुछ भी कर लो, आप छू नहीं सकते. You cannot manipulate it. You cannot, change it. Unlike the slide in a microscope, just where you can keep changing things. And that part was actually very fascinating for me.
What is the first distinct image you remember seeing through a telescope which kind of had a big impression on you?
The moon, the craters on the moon, and the rings of Saturn. I think those are standard, any छोटा telescope, that's the first two things.
मेरे पास भी घर में एक decent telescope है, I think, but moon के crater तो आराम से दिख जाते हैं. I've never seen the Saturn rings.
The thing is, the problem is they don't look that spectacular, choti telescopes, After looking at the Cassini images, we are expecting you'll see all these, nahi, utne to dikhta nahi hai. You see this like fuzzy thing, it's not like, circular. Usme thoda sa you can see the effect of the elongation from the ring, and that's super exciting.
Got it. So you had these experiences as a child, and at some point, like when did you start, committing yourself to actual career in science?
I think the kind of commitment and wanting to kind of really pursue it as a career, वो तो high school में ही मुझे समझ में आया, in the sense that I knew I wanted to do physics. And I didn't want to be an engineer because, I went to Delhi Public School, R.K. Puram, and this was kind of the feeder school for the IITs. And वहाँ लेकिन pure physics degree नहीं था. There was an engineering physics, and then there was engineering, which I was not particularly interested in. And by the time I was in high school, I'd also had, this is the 80s, late 80s. I'd already gotten a taste for research when I was in high school, which was extremely unusual at the time. And that's where I mentioned, right, my parents. So my father used to go to a lot of conferences abroad. And so when I was in high school, when I was in 9th grade or something, he bought me a Sinclair ZX Spectrum, and he bought me a Commodore 64 a few years later. So I learned to program. I was playing with computers. It was a time when, not everybody had a computer at home. And these were not these were desktops. They were not laptops, right? So I think at that point, I suddenly realized that, Asha, with physics and mathematics and computing, I can solve problems. So then I got started. I bugged the director of Nehru Planetarium. There was an amateur astronomical society. Usme main bahut active thi. And I went and asked her one summer, kya aap mujhe project, mujhe kuch karo. And I was, I was like, mere paas computer hai, I can calculate for you, right? And this was a fantastic moment. She's someone whom I'm really grateful for her mentoring, Dr. Nirupama Raghavan. And so she thought I was a real pest, right? And she said she'd give me a very hard problem. And she said, okay, tumko kya pasand hai? I said, I'm obsessed with maps. So that's another interest of mine, atlases and maps.
Okay.
And both of the night sky and the earth. And she said, okay, then why don't you write a program to, wo map aata na, newspapers mein monthly sky map.
Right.
So, haan, wo banao, Delhi ke liye.
Achha.
So I set off and I actually worked really hard on it. I had to teach myself, spherical trigonometry. And then needed to put in by hand a lot of data. And then I did it, and she didn't quite believe me because, it's not laptop, nahi tha na, print out. I don't know if you remember the paper that has the notches on the two sides.
Dot matrix printer.
Dot matrix printer. Usme main bana ke leke gayi thi. And then she said that, this is great, but what if you end up going to Boston for college. Just out of the blue, she said Boston. And what are you going to do then? I said, oh, I've written the program in such a way, you put in a latitude, longitude, and it'll make the sky map. So at that point, she told me later that she realized, okay, this is a serious kid. And then she gave me a problem to work on, a research problem, and I worked with her. So at that point, I knew कि India में मैं पढ़ नहीं सकती हूँ, क्योंकि research is not integrated into the undergraduate curriculum.
Right.
And I felt very much that I wanted to go to a place. And at that time, I found out from going to the USEFI that there are a few universities, the top universities in the world, that actually give you financial aid for undergraduate study. And that's how I ended up. And of course, once I ended up at MIT, it was heaven.
So you started your undergrad at MIT right after high school.
Yeah.
I mean, if you recall, your MIT application at that time was about that I want to be scientist looking at astrophysics stuff.
So my college essay was about watching a launch from Sriharikota. And I had watched a launch, one of the early PSLV launches from Sriharikota.
During your high school days?
Yeah. And it was deeply, it made a deep impression on me about just the wonders of what technology can do to deliver you science, right? So that connection between science and technology and discovery and breakthrough, I think that was already kind of, sparking in my head at that age. So that was my essay. And I went to MIT very much wanting to explore. So I knew I wanted to be a scientist, but I also had a lot of other interests. So I was very interested in history, very interested in literature, poetry, philosophy. So at MIT, I started doing sort of courses in all manner of things. Of course, I was doing mathematics and physics and computer science, electrical engineering and computer science, but I also studied anthropology. And, the only other profession, often, people ask me that, what could you have done? For a nanosecond, not longer, I considered architecture. Because there's something about visuospatial kind of structures that kind of attracts me. And so my first research project at MIT was actually in the architecture of Venice from 1450 to 1520. And of course, उसका ये था plus point था कि Venice को ticket मिल रहा था उसके बाद. So वो भी incentive था. But,
These incentives matter, especially
when you're young, right?
Sriharikota thing actually reminds me of a story I want to share. So in 2018, I invested in a startup here called Skyroot. उसको just two kids out of ISRO and said, we want to build a company which will make rockets. So I invested in because they're very ambitious and work closely with them. But 2 years ago, I got to go to Sriharikota, watch their first launch from the control room. And as you said, it's surreal. I mean, you read so much about rockets and so on, but watching especially the first one go into space and realizing that as humans, we have all the technology to be able to do that. And plus, after that, I also looked up the history of Sriharikota. It was, I think, when it started in 60s, it used to be an old church. And in those days, they're building those tiny 5-foot rockets and we'll use bullock carts and things. It's just fascinating story how far ISRO has come from extremely humble beginnings. So coming back, Priya, to so you're doing your undergrad at MIT and you were clear that I'm going to go into research and do PhD, etc.
Yeah, but I think which particular branch of physics, that I was a little unclear. So I had started research at MIT with on the early universe and cosmology with Alan Guth. And so, particle physics.
He got a Nobel Prize later, right?
No, not yet. Not yet. He proposed the inflationary universe. It's definitely a remarkable breakthrough idea. Fingers crossed. Let's see.
Okay, so maybe he's one of those guys in physics where everyone knows he should and he will, but not yet.
Yeah, I mean, I think part of the issue is that the idea of inflation is so general and generic that, that it's hard to satisfy the Nobel Committee's idea of what really counts as observational ratification for the idea.
Yeah, I think that also rattled, I was recently reading about S.N. Bose and his contribution by now is outstanding, but he never could, at least his lifetime, could meet the criteria, unfortunately.
And I think that I recently saw a study about, how many times people are nominated before they get it. It's often hundreds of times.
Hundreds of times.
Like multiple people,
Right,
whatever, right?
Right.
So, but my own take is that perhaps we are paying a little too much attention to let's stick with ideas. So Aaron had this wonderful idea of the inflationary universe. And it was time United States made the big particle collider that was going to be built, the superconducting supercollider. It had just been canceled.
Yeah. No, I remember. So I had, some early fascination with physics and experiment. While I went into engineering, I actually quite closely tracking that SSC. And then I think it was cancelled in 96 or 97. I was also quite disappointed. I don't know why, but I just felt, and that I think has been a US losses. Then all the particle physics stuff has happened at CERN, right? And then CERN is also kind of running out of steam now. Yeah. It was a big loss and kind of they have already dug half the tunnel and it was progressing, and I guess somewhere.
Yeah, I think at the moment, right, the funding crunches are shaping what we can and we can't do in such fundamental ways, right? But so I did a summer internship at CERN when I was an undergrad. But then I decided that there wasn't a problem. I also did a degree in pure mathematics. And, so I was very well placed to work on string theory, which was starting to have, string theory has had waves of excitement.
And 90s was like peak with the Michael Green and stuff.
So, but I wasn't that interested because, for me, what is fascinating is the validation of an idea, to test it with data and to prove it or disprove it, right? I think it's that arc that I find fascinating, that I've always found fascinating. And so with string theory, and that's a criticism that a lot of scientists have also placed on those ideas, they're not yet at a point. They've really moved along, and there's been enormous progress. But, they've really not quite touched where they can be tested in the typical way that we expect in science. So I actually had a bit of a detour in my career at that point. And I was very interested in history and philosophy of science. So I got admission to graduate school. I deferred it by 2 years, and I started a PhD in history and philosophy of science at MIT. And I was very interested in history of ideas, particularly in fields like cosmology, where you can't do these controlled experiments. And, simulations, computer simulations were serving as proxies for experiments, lab experiments, the equivalent, right? And the idea is, how do you create new knowledge in a field where you have a computer simulation? As you know, you have inputs, you put in something and you let it evolve. And while it shows you more complex phenomena than you could simply calculate with pencil and paper, it's unclear that new understandings, new breakthroughs will come from that, because you are putting in the ingredients to start with, right? So that was the sort of interesting problem in cosmology. And also, it's not quite scientific. If you actually take the scientific method and its definition, which nobody does now strictly, then, nothing is really testable, because you can't do replicable experiments. You cannot replicate. Supernova goes off there, that's all you have, right? So that's what fascinated me there. And then I had a complete chance encounter. You know how in life there are these chance encounters with people that you have that completely shift your course. And so I had one of those things so I finished all the coursework. It was a humanities PhD. So I had to learn and the joke about MIT used to be that, people don't know how to read and write, so they can only calculate. So I literally had to read and write. And then I had the qualifying exam, and they said, look, this is a history and philosophy of science, so you have to write a chapter on the history of computation. So the only person who was alive at the time who had actually met John von Neumann, who was also incredible, right, was an astrophysicist called Martin Schwarzschild, who was retired. And, it comes full circle in so many ways, right? The Schwarzschild, yes.
The original Schwarzschild?
Son.
His son, okay.
Yes.
Okay, wow.
And so he was at Princeton, and I went to interview him. And so, we got on like a house on fire, and he said, what are you doing this? I had to give him this long explanation. I'm going to do this PhD, then I'm going to go back to physics and this and that. And he said, why? You should be doing it now. And I said, well, I haven't found a problem I want to work on. So he said, I know the person you should go work with. And he said, I said, look, I want to work on ideas, storylines that are supported by data, that makes predictions. And he said, you should go work with this guy, Martin Rees in Cambridge. And so that's how I ended up in Cambridge. I had not intended to go to graduate school in the UK. I had intended to stay on in America. But that...
Martin Rees definitely got the Nobel Prize.
No.
No? So my science history is all wrong. I should.
No, you're waiting. I think you are, I think all of these people, have done
some very foundational
Yeah,
contribution.
lots of foundation. In his case, I think the problem may well be he's done so many different things that it's kind of hard to pick
Maybe I should
something.
take your advice to not take Nobel Prize way too seriously also. I think,
I think that would be good.
But so look, this is all in your 20s. You are, working with Alan Guth and Martin Rees and talking to, son of Schwarzschild. I mean, this is incredible exposure, right? I mean, this is...
incredible. That's why I tell you, it's been like completely unplanned. It just happened. It just so happened that, I ended up in this place, ended up with these incredible minds, right? And learning from them and being nurtured by them. And even all the other professors that I took courses from at MIT, in computer science, philosophy, took a class with Noam Chomsky, with Marvin Minsky's Society of Mind. It's just been remarkable. Like, I could not have dreamt of this even,
You're making me feel jealous already. I've not even come to, all your contributions. So, but just I want to just maybe go a little deeper into one thing you mentioned, this pursuing for 2 years the PhD in history and philosophy of science. So somewhere, and you said, you studied pure maths and you did, your undergrad in physics. So somewhere it seems like you were intensely curious. It seems like something is driving you. You want to understand something. Why would you go and study history and philosophy of science as opposed to some, modern? Because somewhere you're seeking something. Seems like you're trying to develop some deeper understanding. If you go inside your brain and try to articulate, what was driving you?
I think it's about going deeper and deeper and understanding really complex, difficult, abstract things and as fundamental a level as is possible. So the goal is clarity.
Why?
Mujhe samajhna hai. And I want to understand. I don't know, it's a compulsion. It's a compulsion. It's a real compulsion. It's not driven by externalities. It's an internal compulsion. And I don't know, maybe this is, we often talk about finding a purpose in our lives or whatever. I think, I don't know, it's the quest for knowledge. I know it sounds really trite when you say it that way, but I was never satisfied. Itna samajh liya, okay, finished, I think I know it. Nay, I always felt that there's more to know. I can go deeper, I can understand it better. And also I realized that, I've also been very interested in the public dissemination of science. And I also realized that if you want to explain something to a person who doesn't have the same foundational knowledge that you've built up over decades, then you need a very different level of clarity to be able to do that, right? And just as you need that level of clarity to forge something new, to make new connections, you need that. And you also need that to simplify things. So I think that I found that, sort of my need and compulsion to continue learning. And I like this chain. I think काफी लोगों को ना नए चीजें सीखने में थोड़ा frustration होता है because you hit against your own limitations.
Right.
I actually love that because then you have to go past those limitations. You have to figure out कि ठीक है मैं यहाँ अटक गई हूँ पर क्यों अटकी हूँ मुझे क्या समझ में नहीं आया. Let me go back to the basics and see what did I miss, right? And so I actually like that cycle very, very much. I thrive on it, and it keeps me going.
And you think, somewhere it's connected to, and maybe my question may also sound a bit right, but I like it. I find it fascinating. See, we have some innate need to kind of answer, who are we? Why are we here? How big is the universe? All of that, somewhere the quest that we've been on kind of somewhat connected to, those larger existential question.
Absolutely. And I think also एक और चीज़ है that as I was growing up and as someone who was reading and very aware of the world, I really didn't like the world. बहुत messy है, complicated है, unfair है, unjust है. So it was always an escape to kind of be in one's head and also to be looking outward into space science and to be like away from the daily grind, right? So I think it's a certain kind of transcendence that gives me a lot of joy and happiness.
One can say like most of your career trajectory has been truly about, following your passion, following your heart. वो advice so सब लोग देते हैं, मैं भी देता हूँ, but very difficult to actually, it also requires some bit of luck, some determination, also some ability to follow the unconventional path and not worry about consequences or, optics of things. So you pursued your, heart, passion, calling most of your life. In 2024, you were recognized as, top 100 people by Time magazine. What about your work, which, landed you in that list? Why does Time care about your work?
No, I was pretty stunned because, as far as I had seen before, Time mein there were, politicians, movie stars, scientists to zyada maine dekhe nahi pehle. And so I was pretty stunned. But I think that what was interesting was that, when they are looking at people who are trying to change the world, they are not just looking at people who are changing the world with politics. They are looking at people who are reshaping our thinking in some fields, some ways, in new ways. And I think it was kind of the work on the first black holes, the new and the validation of that idea, and the fact that idea, and because of my training in history and philosophy of science, also I had been writing and articulating, I was able to do the work, but I was also able to, jaise yoga mein kehte hain na, witness. I was able to witness it from outside. And also see with the lens of someone who is a philosopher of science, कि इस idea में इतना pushback क्यों है? Why are people so resistant to a brand new idea that is bucking the convention? So while I was working on that idea, I was also able to examine from the outside. I think this is the other thing that I really enjoy and that, my life trajectory has given me. The capacity to be an insider and an outsider at the same time. And it's a huge intellectual advantage if you can put yourself, but also in life, I think it gives you perspective. So I think in a way I had, people who had followed my writing with my book, with my other writings, as well as my scientific papers, they could see how a radical scientific idea is proposed. What's the pushback? How does it eventually get accepted? And, one of the people on the jury told me that one thing they found fascinating about me was that how my work over the years, and particularly culminating in that year, actually revealed the process of science to people.
Got it.
And that it was so emblematic of what science is about, right? About how scientists as a community with a lot of domain knowledge reach consensus and it's very rigorous scrutiny of any idea, and that it has to stand the test of being confronted with observational data and validation, right? So I was very grateful and it was an amazing experience. I had not been on a red carpet before that, that kind of red carpet. I'd been on the red carpet, the scientist red carpet I had been on. But this was next level.
How does scientist red carpet look like?
The World Science Festival. So Brian Greene and Tracy Day organized this amazing festival in New York City.
हर साल होता है?
हर साल होता है. And scientists are treated like royalty. So there's a red carpet. And
अभी वो भी है breakthrough prize, वो तो थोड़ा वो Hollywood style.
हाँ, वो थोड़ा Hollywood style है. But this is much more centered on the scientists and on the science. And so I'd used to that, but this was next level.
Did it change things for you, how you approach your work?
No, but I think what it has given me, and I'm realizing that, and of course I didn't do anything to leverage it or whatever, is the reach. I think a lot more people know about my work. And I think it's helped the case of black holes.
Right.
I think that, a lot of us people doing, interesting things in terms of discoveries of kind of catapulting. Black holes have always been fascinating for
And
the
I have a
public.
challenge for you on black hole. I'll come to that, but since you mentioned, you also had interest in science communication. I think there's a book that I think this is 4 or 5 years ago.
Nay, more than that, 2017.
I read it for a while back. Immensely enjoyed mapping the heavens, the radical scientific ideas that reveal the cosmos. And it's also not a very big book. तो आप थोड़ा इसका motivation बताइए कि while you're doing serious science work, publishing papers probably or day job, तो क्या motivation था? आप इसमें क्या communicate करने की कोशिश कर रहे थे?
In the last 100 years, there's been like remarkable progress in cosmology, just in terms of understanding the contents of the universe, the fate of the universe, our place in the universe. Radical shifts have happened. And I felt very much that the public should be in on this excitement because I was living this. This was, I'd been so fortunate to be sort of in the middle of a lot of things unfolding. And I thought that, connecting and showing how the astronomer Hubble's first sort of discovery of the expansion of the universe led then to the 1998 discovery of the accelerating expansion of the universe, which then revealed the potential existence of one completely unknown constituent of our universe, dark energy, which we still don't know what it does. We know how it manifests in the universe, and we don't know what's the origin, does it really evolve over time? Is it constant? We don't know that. So I felt like very much that there's a lot of excitement in the field, and I wanted everyone to be in on it. So I wanted to share that. But I also wanted to do a couple of other things with, it comes from my interest of maps. And I wanted to show how, mapping is really knowing in a very deep and fundamental way.
Yeah.
And जैसे हम ज़्यादा new planets find कर रहे हैं, सब ये new maps बन रही हैं, they're totally reshaping our understanding of the cosmos. And I had the interest in the history of those ideas. And I was very keen on showcasing when I can. कुछ breakthroughs India में हुई हैं, ancient India में, China में, Mesopotamia में. And that doesn't get as much play because we are so focused in the today and the future that we often forget where these remarkable beginnings, right? When human beings were just looking up at the night sky like Neanderthal and trying to correlate the celestial and the terrestrial, right? And how then astronomy as a science kind of grew. So I wanted to show all of that, which I felt that the public would be very, very interested in.
What are one or two things, cosmology related, or perhaps even recent breakthroughs or understanding over the last few decades that you think everyone should just know?
I think everyone should just know that, the constituents of our universe, that we know the constituents of our universe exquisitely. We have a good inventory, but we don't know the true nature of the bulk of our universe. It's only 5% that the atoms that we are made of that we understand very well. Everything else is ununderstood. And that portion is what is driving the universe, its past, present, and future. And then everyone should know that we have now discovered 5,000 other planetary systems around other nearby stars. And we have looked very nearby. We have not really ventured far. And this has completely shaken our sense of our significance in the universe, right? The fact that we are simultaneously very significant because we have the capacity to do all of this, but totally insignificant.
Right.
That itne zyada aur planets hain, so it's quite likely there's some kind of life somewhere, and that we are not that unique. So I think, some cosmic humility is called for from understanding.
And as we're finding more and more planets, where is the state of the art of research of being able to detect some kind of signals of life out there? If it is there, we don't know, the so-called Fermi's paradox. But if it is there and these 5,000 planets we have mapped, I'm assuming this map is growing every year, are there at least theoretical possibilities that we can, from what we can see some signatures, or is it just...
नहीं, अभी तो stage में नहीं है. The other thing, there's a big debate, right, about life. What constitutes life? And we have to break out of our anthropocentric view of life as human life forms and life forms that are familiar, jo humko Earth mein dikh rahi hain. It's quite possible that you don't have a carbon-based life. There are other ways. In fact, Stephen Jay Gould, who's a very famous evolutionary biologist, had said, even on Earth, agar aap evolution ka tape reverse karenge or fir you rerun it aage, you may not end up with us because there's so much randomness that has shaped the fate of evolution on our own planet, right? That it's very hard to know what could be the potential origins, all possibilities for origin of life. But obviously the things that people are focusing on is organic molecules, complex organic molecules. Abhi tak to kuch conclusive nahi hai, but the other thing is our own understanding is water is essential. So they're also looking for water everywhere. So usme to there are good indications that Moon and Mars mein to ancient water to tha. And other, Enceladus has, there's a lot of ices everywhere, and people are very curious now to see, ab dekho kya hota hai, what we find in terms of more complex molecules. And then, there's much work to be done to link that to actual life forms. But I think it's a very, very exciting area of research right now.
If we're lucky in our lifetime, we'll find some conclusive signatures, and that will, I think, probably shift things fundamentally.
I hope so. And I hope that even now, right, this prospect that kahin bhi aur definitely hoga, kahin aur hoga, kisi aur shape or form mein hoga life, should make us feel super grateful for our Earth and be better stewards of the Earth, right? And try to tackle climate change and mitigation as a big kind of urgent concern for us.
Okay, now I'll come to my challenge, which is, and Sunidhi and Delphi, I hope you guys are around. Maybe you can stand up nearby. See, black holes are fascinating. As I said earlier, कि black hole जब भी headline में आते हैं, तो people pay attention. If you have to explain to, Delphi and Sunidhi here and, listeners like them, why is there so much fascination about black holes? Why should they care? Why it matters to us? Why black holes command so many headlines?
Right. So, black holes are some of the most fascinating objects in the cosmos. And I think the reason for fascination is the very peculiar properties that they have. There's a set of very peculiar properties. And, we are seeing everything in the distant universe with light. And it turns out that black holes and dark matter, the two things that seem to be very important in shaping how stars form and galaxies, everything visible forms, they actually don't produce their own light. And they have very peculiar properties, black holes in particular with light, in the sense that they actually are revealed, their presence, they are invisible, and their presence is revealed very indirectly by what the intense gravity does to light itself. So to understand this sort of fascination, and I carry this fascination with me, even as someone who's working and thinking about black holes all the time, and I think, every kid is fascinated because they've heard not even light can escape a black hole. And so that seems, really unfathomable because that's telling you that gravity is so intense that it kind of grabs onto light and you can't escape from there. And the fact that right around the black hole, you have this region called the event horizon. And it's a point of no escape, even for matter, for everything, basically, not just light, but in fact, everything. And so to really comprehend that the density, you can think of black holes as, concentration of matter. You can think of it as a region. I think the more scientifically accurate way is it's a region with intense gravity where matter has gone in and has not come out, and neither has light. So I think it's this kind of bizarre property. We are used to celestial objects like stars that are radiating or planets that are reflecting, but we've never, I think the fascination is this sort of intense gravity, and we've kind of built this picture that they are kind of cosmic vacuum cleaners. They are like sucking everything, right? But then they're very counterintuitive in the sense that, outside this event horizon, from outside this event horizon, black holes also launch jets. They also push matter out somehow. So I think they have this sort of properties that are very counterintuitive and appear contradictory. And they seem to defy the laws of physics, which is kind of true in the sense that the interior of a black hole, it really does defy.
Physics can't describe what happens inside black hole.
Not in great detail, not with the kind of microscopic detail that, quantum mechanics can explain so many other phenomena, like even interference of light and stuff. So we don't have that kind of microscopic description.
So look, on one hand, black hole has this mysterious aura around them. People have fascination about, what will happen if I reach, event horizon, and what will happen if black hole happens to pass by our solar system and those kind of things. But from science point of view, are black holes also fundamental to kind of our deeper understanding, the kind of question you're talking about? Are they also linked to, if we have to understand what is all this, how does all work, it will require us to kind of develop a much deeper understanding.
I think black holes are fundamental to getting a deeper understanding of gravity, the nature of gravity. And scientifically speaking, right, the black holes also represent in many ways the limits of our knowledge because, there's a singularity that's encased, and that singularity is where all known laws of physics break down. And we have another singularity that we deal with, which is the Big Bang. We don't know what happened before the Big Bang. We don't have the language quite yet to understand that. But that's a very different kind of singularity. And however, it's also possible that you can make black holes very, very early on in the universe. You can make primordial black holes. So I think these sort of punctures in space-time that are fundamental to the building up of gravity as the most consequential force in cosmology, all of that really lies and is intertwined with our understanding of black holes. And of course, the interplay of quantum mechanics with gravity, quantum gravity, we don't have a theory yet. We have great attempts, but we don't have a theory yet. We know that, our understanding of the fundamental forces in the universe is actually incomplete. And we know that Einstein's theory of general relativity, super successful as it is there is probably something that is a covering theory to it, in which all known forces are integrated, including gravity at a microscopic level. So, वो तो अभी हमको glimpse भी नहीं मिला उसका. So I think that's the ultimate kind of question that scientists have been trying to see if black holes can be laboratories for understanding.
So black holes in some way represent in some ways limits of our knowledge, but wherever the limit of our knowledge is, other side of that possibly holds a clue.
Exactly. It's the lab to push past that limitation, but also it's a limitation.
Right. So now let's come back to where you started, your day job. What aspects of black hole you are interested in? Maybe just give a glimpse of some of the contributions, Priya, you and your group has made in our understanding.
So I think I've been interested in the origin question, the origin of the first black holes.
Achha.
And the ways in which you could make, we call them black hole seeds, and the multiple ways. So people didn't believe that there was more than one way. And now I think the data is showing us that black holes are ubiquitous. They're just everywhere, littered everywhere, early universe nearby, far away, different sizes, and therefore there ought to be multiple mechanisms by which nature makes them.
Today we don't know what all those mechanisms are.
I think we have a reasonably good idea of many of those mechanisms, but some big open questions remain. Like whether right after the Big Bang, we formed some black holes, a population of black holes called primordial black holes. We don't know that yet. I think we are all studying to see what the consequences of that might be. But I think in the much later universe, whether can you form, there are now some very credible ideas that can be tested, which show, for example, not quite primordial black holes, where you can probably make black holes before you make the first star. And so, so I think that the complete reshaping of our understanding is happening. And this is the thing that I'm most fascinated about right now. And that they are getting observationally validated with data. And, upcoming telescopes, ground-based LSST, Vera Rubin Observatory in Chile, which has been commissioned now, and Nancy Grace Roman Space Telescope, which hopefully will be launched next year. These are going to be survey telescopes, and they are going to reveal the dynamical part of black holes, the variation in the signatures of light across the spectrum that is coming from around black holes. And the variations in the light, the sort of time domain phenomena, new kind of data that we're going to get, new cadence where we can follow it for 5 years, 10 years, all objects in the night sky, is going to reveal, I think, that black holes are implicated in many more things than we currently know. So I think the discovery space is not only wide open right now, but I think very ripe for further breakthroughs.
And these breakthroughs, let's also try to connect it back, because these are also very expensive enterprise. A lot of investment is required. The further we want to peer back in the universe, we need, that much more powerful instrumentation, career scientists like yourself and, many others. So one is it helps develop deeper understanding. We can probably answer some fundamental questions. It also helps immensely with science fiction movies like Interstellar and others, whatever, parallel universe and whatnot. Any practical implication here on Earth as well from all this understanding?
Yeah, so I think I'm often asked that, have you made anybody, does this work make anybody's life better? So, the thing with fundamental science, right, as you know, is that the kind of algorithms, the methods, the techniques that we are developing in the study of black holes, those techniques, those very ideas and conceptual frameworks are used in many, many other ways that directly benefit, where you can see the translation immediately. So, एक मैं example आपको बताती हूँ. जैसे I also work on dark matter, so mapping dark matter, and that's by deflections of light. And so we developed many algorithms to basically look at the distorted field of light, of distorted shapes of distant galaxies, and looking at that to back out how much dark matter you need to have had to give you this distortion. So image processing, basically. So the same algorithms, the same ideas that we have all worked on, who work on mapping dark matter, they're actually used in studying medical scans, medical imaging scans. And so I wouldn't be surprised if very soon there would be AI training sets to read scans better, our body scans better, that will be trained on kinds of images that we have gotten with light bending in the universe. So I think that often we think that fundamental science is not really benefiting society immediately. It's the long term. It's a longer term, and they're completely unpredictable gains. जैसे ये phone है, ये the iPhone that I'm holding in my hand, you would not have this without physics, without fundamental physics. Every little element of it. Without Einstein's theory of general relativity, GPS nahi hota. There would have been no space, satellites, nothing. We wouldn't have been able to launch anything. We wouldn't have been able to find out where you are right now, right? And without this. And of course, every component, electronic component, has come out of a fundamental understanding of quantum mechanics. So I think the arc we often forget and we take for granted when we're looking at the phone, just because as a society, we don't spend any time trying to understand इसके अंदर क्या चीज़ है, ये how has it come to be? And I think it would be really important for people like you, who are doing all this work in spreading the word of science, to really show people how things work. And how everything really derives from fundamental understanding of nature's laws.
Right. And Priya, so you, through your career, you work with some of the top people in your field in the world. You have made a lot of seminal contributions. From your vantage point, how does the arc of Indian science appears to you? Are we also keeping pace, getting better, making contributions, or a lot of work to do?
I think we have a lot of raw talent. There's no question about that. But I think that we have a lot more work to do in terms of building ecosystems where scientific advances can, scientific work can thrive, and that we can actually tap into the talent and sort of the diversity of talent that we have. I think we are not effectively tapping into the talent. And I think that we are not giving room in what we have set up as research institutes for people to innovate, to be bold, to come up with radical things. And, I think that is going to take a little bit more time, but also a lot of very conscious effort. And I think we need to put a lot more effort into trying to understand the conditions that the most successful laboratories, the successful departments, successful institutes, what are those conditions that alive kind of engagement, criticism, constructive criticism, engagement, and activity at a high gear, right? What are those conditions and how we can translate them to the Indian context? I think I'm very optimistic for Indian science because, we have to understand, right? For decades and decades, scarcity mein the. We were not an economy that had the privilege to be able to siphon a lot of money. And it's really hats off to the early pioneers in our nation that, space sciences really did get a boost and that we did invest. And of course, we have fantastic ISRO. ISRO is unmatched. And I think the fact that we can do something like ISRO shows you that we have the capacity. It's just figuring out the right conditions and building a culture that promotes, collaboration as well as, the kind of competitiveness that is very constructive. And I think many institutions, the successful research institutions in the world, have managed to cultivate that. And, at various times, like we've all read about how Bell Labs had that very special kind of, cultural mix, culture of science and discovery. I think it can be done because we have fantastic talent.
And are you able to collaborate with some of the Indian research institutes?
Yeah, so I think not having studied here at all, after having left right after high school, I don't actually have deep connections in terms of having studied somewhere where I know a whole set of people. But I have a lot of people who are working now in India who came out to the US and Europe for postdocs, whom I've collaborated with and have come back here. And I've always been kind of looking to recruit, and encourage bright, talented students to apply and pursue fundamental science both in India and abroad. And now I'm at a level where I do serve as an advisor to visiting committees to places, and I'm able to share some insights from the various places that I have seen, from my experiences at MIT and Cambridge as well as Yale now. So I'm very optimistic, but I think it has to be done very deliberately and intentionally.
And what will be your advice to younger students who are perhaps considering career in research and want to consider astrophysics, cosmology? This is again, it's probably fundamental as it gets. What will you advise both to encourage and things to watch out for?
Right. I mean, I think that this is obviously it's a very personal take, and I really think, as I've mentioned, that I have been obsessed with deep understanding, deep fundamental understanding. So my advice to young students starting out is to focus on the basics, have a very deep understanding of physics, mathematics, and learn computation. And find, you don't have to start doing research in your 5th grade or 6th grade in school. You don't have to find a research internship. What you really need to do is master what is being taught in terms of fundamentals. That foundation once you have that solid foundation, then you are able to really think out of the box. Once you have that and you know the tools that you have a very large and capacious toolbox. Uske baad, that's when you can start sparking. So I would say that mastery. Kuch bhi karna hai, I think one has to master it. I think being obsessed with that. So I don't like to, I didn't want to use the word, but it's excellence, right? So excellence is a slightly loaded word, ke kiska excellence, kiska definition, yeah. But just mastery of the foundations. But then, yes, I think delving into research, getting a little bit of experience, trying to do research. And I often find with young people that they very quickly get obsessed with, ki mujhe paper likhna hai. So it's not about writing the paper. It's about doing that calculation, doing a calculation that might be of interest to others, but first of all, is satisfying to you. Even if it's a calculation that somebody's done before, there's some joy. And I want people who want to be future scientists to capture that joy, because I have that childlike joy still. वो किसी और ने कर रखा है, it doesn't matter. I do it myself, I do it my own way. And that is such a kick. You get a kick out of it, right? So don't lose that kick. Don't get obsessed too early with the careerism of science. Try to do it for the joy. Try to look for the joy in it. And if you do, and then you are lucky and you are in the right place at the right time, and you are able to take advantage of the opportunities, because I have also seen there are a lot of people who do get the opportunities but are not able to seize them because they don't realize that that's a unique opportunity. So I think being aware of that, someone who is young can really forge a very nice, I say a life of the mind. As a scientist, and therefore career, and you can get paid for doing that. Right.
And speaking of right, this is maybe my kind of last question to you, and somewhat of a bit of a crystal ball question. Of if you look at next 5 to 10 years, maybe I can divide in two parts. What are the likely breakthroughs, and what would you like to see get answered?
Likely breakthroughs तो बहुत मुश्किल है. It's very hard to predict the course of future science. Kuch pata nahi kahan se, who will have that incredible insight and synthesis of connecting two things jo humne socha kabhi connect nahi hongi, and then out of that something is going to come. I don't know, right? I can only tell you about the things that I am fondly hoping for and looking forward to, right? I think what would be amazing would be for us to discover a cluster of the first generation of stars. They are supposed to have very peculiar properties. We know what they are. We have simulations. We have reasonably good theoretical understanding, but we've not detected them. So discovery of those and the discovery of the collisions of supermassive black holes.
Excellent. I think you have one of the coolest jobs in the world, Priya. And great to talk to you, Priya. Thank you for taking
Thank you so much. Yeah, thanks for inviting me.
At SparX, we aim to bring to you stories of exponential impact. We share in-depth analysis of what goes behind success stories. If you find our conversations interesting, you can join us by subscribing to our YouTube channel. You can also listen to SparX on Spotify, Apple Podcast, or any other audio platform of your choice. If you have any suggestions on who we should invite or what topics we need to cover, just let us know in the comments. We are always listening, looking for ways to improve, and keep getting better as we go along.